Hey everybody, welcome back to Algebra 1. Today's edition, we are going to use the quadratic formula to apply it to real-world situations. Here we go. So Kim wrote the equation right here to find the time in seconds for an object to hit the ground. So she wants to know how long it's going to take for something to hit the ground. So in other words, we want to know when it is equal to 0. Okay, and we're going to round our answer to the nearest hundredth, because it may not necessarily be a nice number. So in other words, throwing something up in the air, we want to know when this thing is equal to 0. Equal to 0. All right, so here's what we have. We have negative 16t squared plus 64t plus 190, and I'm going to write the equal 0 on this side. So we should be able to determine what A, B, and C are, since this is in standard form. In other words, it does equal 0. So A, negative 16, B, 64, C, 190. All right, so let's set up our quadratic formula. We have negative parentheses plus minus our square root with parentheses squared minus 4, and then we have two sets of parentheses. All of this is divided by 2 times parentheses. And so if you remember, right, we want to know, hey, when is A? We're going to identify A. He's going to go there and there. We're going to identify B. He's going to go there and there. And we're going to identify the weirdo, C, and he's going to go there. So here we go. We have 64, 64. We have negative 16, negative 16. I put exactly what I have here, nothing more, nothing less. I don't care what's on the outside of these things. Okay? And then I put my weirdo, 190, all by himself, all by his lonesome. All right. So now we're ready to calculate some things. The first piece to this is, if you remember, we're going to take this piece. It's the opposite of what we see here. So in other words, I see a 64 inside the parentheses, so with the negative out here, it's going to be negative 64. And if you recall, we had a little hiccup. You can't just type 64 with a parentheses or negative out in front. You got to make sure you attach a 1, a negative 1, because you're negating this parentheses here with the negative. So then we have our plus minus, and then we want one number underneath the square root. And then we can take 2, and we're going to multiply that by negative 16. So put that in there, and we get negative 32 at the bottom. Okay? So I want one number underneath the square root. And so how I'm going to do this is I like to do little dotted lines all the way around it. So that way we know, hey, this is what we're about to throw in there. So parentheses squared minus 4, parentheses, 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 parentheses. All right, what goes in the first parentheses? 64. What goes in the next one? Negative 16. And then what goes in the last one? The value of C, which is 190. And that gives me 16,256. And so now we want to say, hey, what is the square root of 16,256? And it's something poopy, right? This is real poopy. And I can't change it to anything that's not unpoopy. So in other words, here's what we have, and I'm going to break this problem into 2 now, right? It'd be like where our little squiggly comes in play. Squiggly, squiggly, squiggly. So we have fraction bar with negative 64 plus the square root of 16,256 over negative 32. And then we have negative 64 minus the square root of 16256 all over negative 32. And so now what we want to determine is, what are those weird poopy numbers? Negative 64 plus the square root of 16256 over negative 32. And I get negative 1.98. And then here, change it to a minus sign, and I get 5.98. And so we're talking about seconds, right? We're talking about seconds. So can I have a negative 1.98 seconds? Does that make any sense? Is that reasonable? No, we're talking about an object going up into the sky, and then it comes back down, and it's going to hit the ground at about 5.98 seconds. So let's graph this and see what we can come up with. So we have negative 16 t squared, or x squared, plus 64x plus 190. And so I look and I determine, hey, look at that. There is my answer. So here's how you find it mathematically. We can also use some reasonableness to say this doesn't make any sense. And this does make sense because it does have a positive value. I can go up and I can hit the ground, come back down. All right, let's take a look at number 2. Number 2, a ball is thrown straight upward at a 50-foot building. So this is the 50-foot building, okay? And it is at a speed of 64 feet per second. Here's the function. Hey, look at that. They give us the equation. All right. Cool. Look, here's the equation that describes the ball in the height that is above the ground, okay? How long will it take for the height to equal 30 feet above the ground? So in other words, I want to know whenever it's basically going to land at about, if this is 50 right here, right? This is 50 feet. Then let's say maybe something right here is 30 feet. That's really what I'm wanting to know, okay? But here's the thing. We're going to take our values. So we have negative 16 t squared plus 64t plus 50, and that equals, because I want to know when it's at 30, okay? Well, wait a minute. I need this to be in standard form. So what about if I move this guy, right? He needs to go over here. And if he goes over there, I'm going to subtract 30, right? I'm subtracting 30. So now I have negative 16 t squared plus 64t. 50 minus 30 is positive 20. And now that equals 0. So what I want to do now is I just want to determine, can I do this from the calculator? Negative 16x squared plus 64x plus 20. Can I determine where this crosses the x-axis? Yes, I can. 4.291 is my reasonable answer. So this would become where x, or my time in seconds, is 4.29 seconds. So the next problem, we have, which of the following correctly shows the quadratic formula being used? So I have 2x squared minus 9 equals negative 7x. And I want to know which one was substituted in correctly. All right, well, before we do this, we got to make sure that it is equal to 0. So in other words, this guy, right, he needs to go to that side. So I'm adding a positive 7x. Okay, well, wait a minute. That is not my constant term. So now what I have is 2x squared plus 7x, right? And then the minus 9, he's my constant term. Now this equals 0. And so now I can say, hey, here is A, here is B, and here is C. So which one substituted correctly? All right, well, if I put 7 for B, then I know these need to be like 7s. And it actually, okay, so -7. So this is gone, right? And then I know that the 2 is going to go here and here, right? Here and here. So that doesn't really help me. And then the -9 is going to go here and here. Oh, wait, no. So this is the -9 right here, right? So this is my answer, A. And B is no good because it's a +9. All right, guys. Thanks for watching. We'll catch you next time. We'll see you later.